these are the notes for section 3, chapter 3. It's on arithmetic progressions. An arithmetic progression is defined as a series where a sub 1 equals a and a sub n plus 1 equals a sub n plus a common difference that we call d. So this common difference will be constant, it won't change. So d will always stay for a single series, d will always stay constant. So you get an example of this series 1, 3, 5, 7 dot. We can describe this if you look at a1, a2, a3, a4. Well, we know a1 equals a, so we can say a equals 1, and the common difference will be a of n, so let's try a of 2 will be equal to a of 2 plus 1, and then plus some constant d. This is equal to a of 3, so put 5n. A of 2 is equal to 3 plus d, and since 5 equals 3 plus d, we know d equals 2, and that's all we need to describe an arithmetic progression. It's just the initial value and the common difference. And so if you think about it in a different way, you have a1 equals a, a2 equals a plus d, a3 equals a plus d, or a plus 2d, then a4 equals a plus 3d, and so on. We can rewrite this as a sub n equals a plus n minus 1 times d. So if you look at this, a sub 3 equals a plus 2d, and that happens if we get that kicked out. And this allows us to find one of any 4 variables. That could be a, n, and d. And given any 3 of these, we can find the 4th one. So let's say we're looking for the, or well, I guess a sub n and n are basically the same. Well, not necessarily, but they're very similar. Say we're looking at a sub n equals 120, and the initial value we'll say that's 10, and we'll say our common difference is, I don't know, 11. And so from this we can say 120 equals 10 plus n minus 1 times 11. Then we can simplify this to get 110 equals n minus 1 times 11. Divide both sides by 11. 10 equals n minus 1, so that means n equals 11. So we can say that 120 would be the 11th term of the series where the initial value is a and the common difference is 11. And then on top of having a formula to figure out just a given part of the series, we also have a formula to figure out the sum of the series, where we're going to define it as the sum as k equals 1 up to n of a plus n minus 1, or I guess k minus 1 times the common difference d. And so the way that we're going to define this is by calling this series S. So erase this first base, define S as equal to each of those terms. Excuse me, a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d, all the way up until you hit a sub 1 plus n minus 1 d. And now what we can also do is define S as okay, so what we can do is we can flip all this around, because I think that this is also equal to a sub n, Then we'll have, and then this would be a sub n minus something amount. So we start with a sub n minus, or plus a sub n minus d plus a sub n minus 2d, all the way until you have a sub n minus n minus 1d. And if you think about it, this is just working backwards. A sub n equals this, a sub n minus d would equal somewhere here, and this last term is equal to this term. And so what we can do is we can subtract these two expressions, so we get a sub 1 minus a sub n. And then if you look at it, oh wait, no, sorry, why am I subtracting it? I'm dumb. A sub 1 plus a sub n. And then, now that I've added those properly, then we can see that these two, this d and this d will cancel each other, so then we'll just get a sub 1 plus a sub n. This will just keep going. Now we have a sub 1 plus a sub n. And you can figure out how many times this happens because it's equal to the amount of terms in the series, in the initial S series. And the series is defined as 1 to, as from a sub 1 all the way to a sub n, so that means there's n terms. Which means that we can just, using our definition, what we know multiplication is, repeat addition, as 2s. Is that 2s equals n times a1 plus a sub n, or s equals n times a1 plus a n all over 2. So, if you think about it, what it basically means is you're taking the average of these two, the arithmetic mean of these two terms, and you're multiplying that by the amount of terms that there are. So if we do an example using the formula that we just derived, all this marker's running dry. All over 2. And so let's say we want to find the results of this sum as k equals 1 up to 20 of 10 plus k minus 1 times 7. So that means our first term is going to be 10, and our last term is going to be some other number. So first off, when we're defining this, we have to s equals, how many terms is there? 1 to 20, we have 20 terms. And then we're going to figure out what a sub 1 is, and so k equals 1, this is 0, so it's just 10. Plus, plug 20 in for this because it's our last one, so 10 plus 19 times 7, 3, 6, 7, 133, yep, so this plus 143 all over 2. So that means it'll be 10 times 153, or look how fast I was instead of adding every independent variable, or every independent term of the series. You can just do it in a few steps. And that should be it for the arithmetic progression section.